Hello, and once again, welcome to the second part of this chapter Semiconductors and Solar Cells, which is produced for school level students, high school level students, 9, 10, 11. If you have not watched the first part, which we discussed about the basic principles behind semiconductors, N-type and P-type semiconductors. If you have not watched, please do so before proceeding with this part, which is on solar cells. You must have seen at different roadsides tens of thousands of solar panels on the roadside, and also some rooftops, which are very common in developed countries like US, Western countries, Europe, Australia, and of course not that very common in India. We are heading towards solar energy to a large extent in the coming 10 years. So this panel, each panel is made up of the basic unit of energy production is called solar cell. Combination of large number of solar cells produces this solar panel. Now let us talk about what is this solar cell. Solar cell is nothing but a combination of two semiconductors. One is N-type, the other one is P-type. And when you attach these two types of semiconductors, the junction between the two layers is called the PN junction. In this video, we are not going to talk anything about PN junction, making it a diode or a triode. No. Simply, we are attaching a P-type and N-type silicon semiconductors, and in the junction, a very peculiar kind of region will develop in the vicinity of this junction. That peculiar zone is called the depletion zone. We'll talk about the details very soon. And these silicon layers which are attached are very thin, very thin, 300 to 400 micron meter. These silicon layers are called silicon wafers. So when you attach N-type and P-type wafers, silicon wafers, then in the vicinity of the junction, PN junction, this depletion zone is formed. That depletion zone is only about 1 to 2 micron meter, while the thickness of each layer is 300 to 400, but the depletion zone is only 1 to 2 micron meter. Now see, the upper layer is a N-type semiconductor written here, and the lower layer is the P-type, and the junction, and in the vicinity of the junction, PN junction, a peculiar kind of region, which is the key, the basis of the solar cell, is produced here. This is called the depletion layer or depletion zone. And light is allowed to fall. Sunlight is allowed to fall. As long as there is sunlight, there is power production. No sunlight, no power production. So as the sunlight falls into the N, it is allowed to fall on the N-type. The top layer is N-type. Then spontaneously electron flows from the N-type to P-type, and you get the benefit of the current, the direct current, the DC current. Although the electron flows from N-type to P-type, the conventional direction of current I flows from, the direction of the current is from the P-type to N-type. This is I. But electron flow from the N-type to P-type. And one cell generates an approximate voltage, a potential difference of about 0.5 volt. Now, this effect is called photovoltaic effect. The energy present in the light photons, UV and visible light photons. You know, the basic unit of energy in the electromagnetic radiation is called a photon. And that energy in the UV and visible light present in the sunlight is capable enough to dislodge, to extract one outermost electron, one immobile electron, not free electron, immobile electron from the silicon atom, and can be able to generate current. So that is therefore is called photovoltaic effect. No chemical reaction, unlike other electrochemical cells, batteries. This photovoltaic effect is different from the electrochemical process by which usually batteries are produced. Therefore, this cell is called a PV cell. What is PV? Photovoltaic cell. Solar cell is also called PV cell. Right? Now, what is the depletion zone? What's the interesting part about depletion zone? Why the name depletion? Now see, what happens, supposing this is the N type, the N side, this is the P side, and this is the junction. This is the junction. And then on the side of N type, once you connect the two, what happens? The free electrons which are present in the N type, remember, due to impurity arsenic phosphorus, those free electrons let loose, slip from the N side to the P side, occupy the holes, because the P side contains abundant number of holes, mobile holes. But once the electrons in the vicinity of the junction, this is the PN junction, slips to occupy the holes in the P type, in the vicinity of the junction in the P side, then what happens? Interestingly, the N side loses electron and develops net positive charge, because the nucleus is not having the required number of electrons. That electron is now not in the N side. So the extra number of proton present in the nucleus will bring about the positive charge on the N side of this PN junction. On the contrary, on the P side, the charge will be negative, because the electrons, they will be occupying in the holes and it will be negatively charged. So there is a small little potential difference across the PN junction, and this potential difference, small potential difference, or the electric dipole, that is the key, that is the starting point of photovoltaic effect. Now see, interestingly, this zone, which is called the depletion zone. Why it is depletion? Because each side has lost its charge carrier. The N side has lost its free electron, the charge carrier, and the P side has lost its mobile holes, the charge carrier. Therefore, depletion means decrease or total elimination or decrease of some quantity. So depletion of free electrons, depletion of holes, that makes the entire zone, which is about 1 micrometer, 2 micrometer in thickness, while the entire, I have shown only a small part, but the entire thickness of one side is about 200 micrometer, but this depletion zone, which has been little magnified, is about 1 to 2 micrometer. That is the real key or the hero of energy production. Now the interesting part of this depletion zone is that it doesn't have any charge carrier. There is no free electron in the N side of the depletion zone, and there is no mobile holes. The holes that carry electrons are now immobile. Electrons are tightly bound to the silicon nucleus, and no longer they are not free electrons, they are tightly bound. And so also these holes, but having positive side, that there is no free electron. But these holes are not also mobile. These holes are not also mobile. The electrons are not also mobile in this depletion zone. So depletion zone has lost all charge carrier. It is almost like neutral. One side there is positive potential, the other side there is negative, small little negative potential, and that prevents further slipping of electron from the n side to p side, because electron will be repelled and it will not be allowed to go from a positive charge center. So after a bit of charge exchange between the free electron and holes, there will be no further charge exchange or free electron exchange with the holes, and that depletion zone is now waiting for the light to fall on it. When light is allowed to fall on the n side, and this side, just you have a look, from this side it penetrates down into the depletion zone. The thickness is only through 200 to 300 micrometer. That is not much for the light to be obstructed. It will be penetrating deep into the depletion zone, and since this zone has no charge carrier, the light has sufficient power. Photons, these light photons which are coming, which will be allowed to fall, will remove one electron from the neutral silicon atom. I'm not saying neutral in the sense, because there is no free electron there. It will dislodge, because of its energy, it will dislodge electron from this silicon. These electrons were not mobile. Let me tell you, they need some energy. That energy is provided by the sunlight, the photons present in the UV and visible light in the sunlight. So once the electrons per atom, per silicon atom, one electron is dislodged, and you get pairs, hundreds and thousands of electron hole pair. Once the electron comes out, it produces a real hole. So the entire region is filled with electron hole pair, and immediately the electrons are attracted to the positive part, that is to the n side, and the holes are therefore migrated to the opposite side p type. So within a moment, the electron concentration, free electron concentration, will be risen to a large extent in the n type, because all the electrons produced from silicon atoms by the bombardment of light photons will be attracted to the positive side, to the n side, and the concentration of free electrons will be more in this side, concentration of holes will be more on the p side, and there will be a real detectable potential difference between the two layers. Now this difference is so much so that once you connect with a wire, spontaneously electron will flow from the n side to the p side, and we say the current is flowing from the p side to the n side, and we take the benefit. So this is just like a battery. The difference is that in ordinary batteries, ordinary cells, it is electrochemical. A chemical reaction is carried out. Spontaneous chemical reaction is carried out to generate electron or current. But here, simply the sunlight is capable to dislodge a immobile electron from silicon atom, and these electrons and holes, they will be segregated to their respective position. Electrons going to the n side, holes going to the I had already discussed what are holes in my first video in part 1. Please do watch. This is the principle. And once the electron is passed, then the depletion zone is now free. It is created again. Again light falls. It is a continuous cyclic process. Again electron hole pairs are formed, and they migrate to the respective side, and they produce a voltage. And voltage, if you join, it is there in a circuit, then circuit will be closed automatically. So as long as sunlight will be falling on the n side, it will be penetrating to the depletion zone, and electron hole pairs will be created, and this cyclic process will continue. So the same, this is the n side, which is positively charged. The free electrons have been slipped to the p side, and now immobile, these are not free electrons. It makes it negatively charged, but they are not free electrons. They are now tightly bound to the silicon nuclei, and these are positively charged. These are also immobile holes. The holes are immobile, the electrons are immobile. Now your putting sunlight. Sunlight will penetrate, invade into the depletion zone and knock out electron from each silicon atom, as I have explained. I have already explained there is no charge carrier in the beginning, but once you apply sunlight, electron hole pairs are formed and they will be segregated to the individual due to presence of positive charge in the n part of the depletion zone. Electrons from the electron hole pairs are quickly transferred to the n layer and holes transferred to the p layer. This results in a great increase in the concentration of free electrons in the n layer and holes, that means mobile holes, in the p layer. Thus, a real potential difference develops between the two layers, and once they are connected externally, electrons spontaneously flows from n type to p type. So the real driving force for this formation of potential difference is the small little electric field which is formed in the depletion zone, so that there is no charge carrier. Then only the sunlight will have its miracle, its magic, amputing out an electron from each silicon atom. And nowadays nanocrystals are used. We will talk about the nanotechnology in a separate lecture. Actually, we talked about two layers, n layer and p layer. This is a hypothetical explanation, just for the school level students to understand. This is called thought experiment, which is not real. Just imagine that there are two layers and we are attaching the two layers and the junction p-n junction, and in the vicinity of that depletion zone is created. It's just a thought experiment, but actually what happens is single wafer, silicon wafer, on one side the arsenic or phosphorus or antimony, the group 15 impurity is added and make it a n type, and the other side of the same wafer some boron or gallium is mixed, so that the other side becomes p type. Automatically the junction between the two sides is called the p-n junction, and there in the vicinity of that you get depletion zone and all magic happens. Now see once again the same thing. This is the n type, the top where the sunlight will fall. P type is beneath, below, and all are connected by the electrical connection, conducting wires, so that you can apply a load to check whether you are getting electricity or not. But as long as there is sunlight, you will be getting. And if you cannot use them, either you sell them, give them to the national grid, they will take your energy, or you store it in a lithium ion battery. If you have not visited or watched my lecture on lithium ion battery for school students, please visit my original channel SST Chemistry, and from the playlist you can find the video on lithium ion battery. It is done both in English medium and also Odia medium. Now there is an alternative explanation. The alternative explanation is based on the band gap. Band theory we have discussed in details in my first video. Please watch. There, what happens due to the formation of this depletion zone, the band gap is lowered. The band gap is lowered for so much so that sunlight, the energy present in the sunlight is capable to pull out electron from the p side to the n side of the depletion zone. Things continue in a cyclic manner. So due to the slipping of electron from the n side to the p side, the level of conduction band is lowered. And because now the electrons have come to the p side, the valence band has gained energy. So the valence band has gained energy, that is the p type, and the n type, the conduction band has decreased its energy, so that the band gap has been reduced. It was previously this much. Once you attach, there is a p-n junction, depletion zone is formed, then automatically the band gap is lowered, and this difference will be between 1 to 2, because sunlight has the energy capable to surmount the band gap 1 to 2. So you will be able to find electron spontaneously jumping from the valence band to conduction band, and as we get electricity. Actually, in the real production of a individual cell, individual silicon solar cell, you have not only the n type and p type. These are the key layers. Actually, these are not two layers. One layer is made up in such a manner, the top layer is n type, the bottom layer is p type. That is, the upper part is very delicate. First, a metal grid is there to conduct, to connect it to the conducting wire, and then anti-reflection coating is there, and then glass is there to protect it. And the lower part doesn't need any protection. So the only metal plate for electrical conduction. So it will be, you'll get one cell, one solar cell. And now when we attach the n-type with a p-type semiconductor, in the upper part it is n-type, in the lower part p-type. A lot of holes are in the p-type and a lot of free electrons in the n-type, and a depletion zone is formed, region is formed in the vicinity of the junction. And because electrons have come away from the n-type, a positive charge side is created on the n side and a negative charge side is created on the p side, and that small little potential difference is the basis of the production of electron hole pairs. Now when the sunlight will come, penetrate through the n-type and falls in the depletion zone, it creates electron hole pairs, thousands and thousands of electron hole pairs. And these pairs, the electrons will be quickly attracted to the positive side, that is the n side, and holes will be coming to the p side. The concentration of free electrons will be more in the n side and holes will be more in the p side. That develops a potential difference. That potential difference, when you connect it by external wire, spontaneously electron will flow and generate current. That is the principle of PV cell. How did you like? And solar panel is a combination. This is an individual solar cell, and a series and parallel combination of several solar cells gives a solar module, and connection between several modules gives a solar panel. So this is a solar panel, this is a solar module, and in this solar module you have several solar cells, and in the area you find several panels are arranged in a systematic manner. So this arrangement of several panels is called a solar array. That will produce a lot of voltage, can be stored or to be sent or sold or sent to the national grid. So that is the end of this program. This is basics about solar cell. How did you like it? If you have really liked it, hit the like button, and also don't hesitate to subscribe to my channel SST Chemistry. Bye bye till the next video.